Hello, everybody. Welcome to the Mindplex Podcast. We are very excited today to be talking about HyperCycle and OpenCog and how they can work together on the path to superintelligence. So, Desi, I will let you introduce our guests.
Today's episode takes a dive into the future of technology with a visionary at the helm of innovation, Toufi Saliba. As the CEO of HyperCycle, Toufi is not just pioneering new paths in technology but is also rethinking the very fabric of the internet. What makes Toufi a standout in the tech world is his fervent commitment to enhancing how technology works for humanity. Today, we'll unravel how his innovations are paving the way for a more secure, decentralized, and efficient future. Welcome back to the show, Toufi.
Thanks for having me. It's exciting to be here.
Our second special guest today is none other than my co-host and visionary Dr. Ben Goertzel. Many of you already know Ben as the CEO of SingularityNET, a pioneering organization that combines the power of AI and blockchain to create a decentralized, open market for artificial intelligences that is also leading the way towards democratizing access to advanced AI technologies. It's going to be a mind-expanding session, so stay tuned as we delve into these fascinating topics with Ben Goertzel.
Yay! Thank you.
Before we dive into the specifics of HyperCycle's technology, could you explain how the concept of an Internet of AI initially came about?
Toufi, that was for Toufi.
Yes, sure. I mean, the Internet of Homo sapien seemed to do a very good job for getting Homo sapien to collaborate and cooperate and compete and do all of the stuff. And like Yuval Noah Harari describes it, that the main reason why we Homo sapien govern this planet is not our individual effort, is more our collaborative and cooperative effort. So we'd like to think that Homo sapien, they're intelligent agents somehow, or knowledge workers, whatever you want to call them. And it turns out that if they collaborate and cooperate, it's a lot better for the entirety. And I guess anyone can argue, and you would see that like the internet, the way we have it, is a lot more intelligent. The whole thing is a lot more intelligent than any single entity on the planet Earth. So, so then, what do we call this thing that to enable the tiny little agent that has been confined to a small environment, such as, let's say, like a Microsoft or HPC center or whatnot? Perhaps they need to be liberated, and we're like, okay, let's call it like maybe the Internet of AI. And we certainly don't want to take credit for creating the Internet of AI. We've kind of said it many, many times. We're creating a tiny little component that we feel it's extremely important, and in fact, it is necessary to enable that collaboration. So it's kind of like frictionless. It doesn't depend on a third party. That's the most important thing. So that's the started with the metaphor and get to where it is.
Yeah, I mean the internet right now is an internet of humans, software programs of various sorts, including AI, right? So I mean the internet already has AI on it and has its own emergent intelligence to some level, but it was not designed to support collective AI at a high level. And in fact, I mean, as we all know, it wasn't designed for what it's now doing either, right? I mean, it was designed for military purposes and sort of evolved in a haphazard way into the internet that we have today. So as we look at how do we create beneficial general intelligence in a decentralized way, leveraging computers running all over the place, owned by different people, doing different things that contribute to the overall, emergent intelligence, it will be surprising if the networking protocols and standards and mechanisms that semi-haphazardly evolved in the early days of the internet in the last century, it will be surprising if this was exactly the right thing to serve as the network underpinnings of an emergent super intelligent global brain, right? And so it's, I mean, of course, what we're building with SingularityNET and HyperCycle and so forth, it's initially running on the internet as such. I mean, it's using the standard internet protocols, and we're adding some additional layers on top that are specialized for the purpose of decentralized AI. I mean, as things advance, you may see even the core underlying internet protocols improved by the AI itself, right? But we're not quite there yet. What we're doing now is we're adding some layers on top of the basic internet that allow us to do decentralized AI more effectively, and we're trying to roll this out at tremendous speed because Lisa, as our friend Ray Kurzweil has articulated many times, the singularity may well be near, right? I mean, we could be just
tick tick. Yeah.
I mean, we could be just a few years from getting AI that's really is generally intelligent than people. And if this AI is rolled out on the good old internet, or the good and bad old internet, without an additional layer designed especially to support decentralized AI, then things may not come out so well.
So would you say
Do you
the
think we can negotiate
decentralized
with Dr. Ray Kurzweil, like the deadline that he set for us? Do you think we can negotiate with
no,
him?
it's not negotiable. Are you kidding? He's been saying it forever. It's 2029.
Totally.
I
Right. No,
I
I
think,
think if anything, it's
I
going to
don't
come
think he's going to
earlier.
be that far off, right?
It's going to be a lot earlier.
I don't think it's going to be earlier. I'm one of these people holding out for 2029. I think we'll be still lucky if we have it by 2029.
It could be a few
Human
years
level
earlier.
AGI.
It could be a few years earlier. It could be a few years later.
People might say they have it a few years earlier, but I'm not sure if it will be, because since it's going to be very hard validating other people's software, what's really there.
I don't know that that's really true. I mean, I understand there's no rigorous test for human level AI, and there will always be people saying any crazy thing. If you have an AI system that can on its own make scientific discoveries, on the par with the best papers being published in Nature or Science or whatever, and that can create new art that just doesn't qualitatively feel derivative and copied off of other people's art, but feels like it's and fresh. And if this AI can talk to you about what it's doing in a way that feels real and meaningful, I mean,
oh wait, ChatGPT can talk to you about what it's doing in a way that's meaningful, but it's not there.
Okay, well, maybe it won't convince you. I mean, maybe a god.
No, I'm asking. No, I'm asking.
It's possible.
I'm asking you because my point is that people think that ChatGPT and GPT-4 and all these
right, but
have more than they do.
I understand. Now, what I said was a sentence with multiple clauses to it, and you can't just extract one clause.
Oh, okay.
From it.
My mistake. Keep going.
What I said was, if that could do breakthrough science on its own, on a par with the best human scientists, and that same system could create, radical new art on its own, on a par with the best human artists. So, I mean, if it could do, something on the level of Stephen Hawking, and something on the level of Prince and Picasso, right, and the same AI can talk to you about what it's doing and why and what it felt while it was making these creations and what they mean to it. I think if you have a system that can do all that, I think most people will accept it as a human level AGI. Now, ChatGPT does not do those things. It just holds basic conversations. I mean, it does not do breakthrough science. It does not do breakthrough new art. It makes bad derivative poems, and it makes a bunch of fake science, and it writes basic Python code. So I mean,
Now,
it's clear.
the science part, didn't
Really,
something
it's-
already happen in the science area where there's a model now that
No.
made, I thought there was a model now that made an interesting discovery. All right, I'll have to figure out what that is.
Well,
and ask you about it later.
people have used genetic algorithms to discover patented engineering and science discoveries back to the 1990s. So I mean, AI has done science long ago, used as a tool by human scientists, right? But I think one could argue detailed criteria for forever, and we don't have a knockdown accepted test of human intelligence either, right? So we could argue forever whether this human is really very intelligent or not, based on,
there's a higher bar.
Yeah, so but I guess in any case, we may be there a few years before Ray predicted, or a few years after. You may be right that Ray is exactly spot on. What's fascinating?
Hey, I didn't say he was exactly spot on. I said that I think it would be at least that long. That's what I'm saying, right? But that's for human level, right?
You might be right. You might well be.
Yeah, I'm just saying.
Wrong.
I didn't say spot on.
What's interesting is that the whole timeline has, the range of timelines projected have shifted quite a lot toward the present, though. So I mean, now you have folks from OpenAI saying, well, maybe 2 or 3 years. You have Robin Lee from Baidu saying, no, at least 10 years. But the fact that the argument is 2 or 3 versus at least 10, instead of 10 versus 100 or 1,000, is a very big shift from the dialogues we were having 10 years ago, right? So I think that projected timeline of AGI is getting closer and closer, and the confidence interval is certainly relatively wide. Like not even Ray or not even Lisa can pinpoint it to a specific. So the important point for this dialogue is, if this is coming in 2, 3, 10, or 15 years, whatever, if it's not 100 or 1,000 years, then it behooves us to get the infrastructure that this AI is running on right. Because if we don't, the AI may end up controlled by a small group of people who may not have humanity's best interests at heart. And this could happen either by a big tech company or big government just building the AI on its centralized server farms and rolling it out for their own good, or it could happen by folks trying to roll it out in a decentralized way, but them doing it on insecure networks in a sloppy way, and malevolent parties just grabbing control of it, right? So I mean,
and even if they have the humanity's best interest today, they might have it. Will they have it tomorrow? They can't even guarantee to their own self if they will have it tomorrow. It's very, very difficult from governance perspective that they would assure everyone, yes, we will make sure that this is going to be in human's best interest if it's governed by a single entity. And if they were to be successful, then tell them, ask them, what if your opponent get there first? Will you be okay with that? And none of them would be. So it seems,
I would be. I don't have opponents.
Exactly.
I would be.
I know.
I'd be okay if someone else
saying,
got there first. Yeah.
No. I'm talking about a centralized entity. So centralized entity controlling it. Exactly. Yeah. That's what I mean.
No,
that's what I mean.
Because, the thing to understand is corporations and governments are their own kinds of which are on the whole less ethical and even more fucked up than individual humans, right?
And they admitted themselves. They admitted themselves. Right? They admitted themselves. That's a shocking thing. They admitted themselves, yet they're coming and saying like, yes, we're gonna take this control over this thing. It's literally kind of like saying like a mosquito is going to control your city or whatnot. Okay, well, the mosquito's intelligence is a lot less than human. Why would we let it do that? So this is precisely the same. So it's But it's also another thing that is extremely important that Ben and I were 100% aligned. When we talk about human level intelligence, many people, they kind of have a certain picture in their mind and they start saying, well, that's not possible because of all the tools that we have. We don't even have a blueprint towards that or whatnot. And I really, really think what we're saying here is human level of intelligence, not human intelligence, human level of intelligence. Those are two different things. For example, if you were to look at certain intelligence that exists on the planet today, there's certain animals that they are perhaps a lot more intelligent than a human at some aspects, but they are so irrelevant in the grand scheme of things. So we might, as a human, you might still find certain people that are a lot more intelligent than this machine at doing some specific thing, but that specific thing may not necessarily be relevant in having this machine to self-evolve itself. He just described. Imagine when you get to this machine that it can do science discoveries and self-evolve itself and all of these things. Remember, it might do all of these without necessarily doing what us Homo sapiens do better at it at some aspects. Okay, so it doesn't really need to do that in order
I think
get to the point and bypass our intelligence.
There's a difference between AGI and ASI in the sense of not the token here, right? Because when you have a human level intelligence, indeed, it may be better than people at some important things and below human level in some other things. Just like I'm worse than my dog at sniffing out some bone buried in the yard behind my house, right? I mean, I'm below dog level intelligence at bone location, right? And I mean that's
Wait,
that's fine.
There's bones buried behind your house. Is there something you want to tell us?
Well,
don't talk about where the bodies are buried on the show, please.
Damn.
Well, this is an operational security issue. Yeah, right.
Okay.
Yeah. So I think for AGI, that's certainly true. You'll have a stage where AGIs are better at math theorem proving, better at crunching big data sets, better at controlling robot stuff, but maybe worse at some things that humans are especially attuned for. I think at some point you get to a superintelligence, it's going to be better at whatever.
Toufi, could you explain HyperCycle's significance to decentralized superintelligence?
Oh, all right.
Oh, wow. Okay, so decided us to...
She's running the show these days, so she decided it was time to move on.
Would you be so kind to repeat that question? Because it came with while others were speaking.
She asked, can you explain...
No,
explain HyperCycle's significance to decentralized superintelligence?
Oh, absolutely. Yes. So the communication between nodes, and this is something that I wanted to cover here, because many people, they say, well, we have the internet. Why do we have another internet for the AI? Well, anyone in computer science, they know if you were to have any machine running and having another machine trying to ask it to do some work, if they are strangers to each other, it is not possible without having to depend on a third party. It's not. And why is that the case? Well, if it's going to go and ask the other machine, hey, can you do some work? The moment you're going to do the work, or the moment that machine is going to do the work, is going to start consuming resources, such as time, such as energy, such as intellectual property, and so on and so forth. And as soon as you spend those resources, you end up creating certain thing that is called value. And if you were to create that thing that is called value and you want to transmit that value back to whoever is requesting it, the other agent, AI agent here, remember we're talking about AI, talking to AI, and you need to be so sure that what you have consumed is actually going to be 100% paid for and not maybe. And therefore, if you depend on a third party, it guarantees that. And that's been the case since 1983. And that's why many computer scientists, they said that this is not possible, including one that I talked to maybe a few days ago. Now, here's the thing. If we're able to enable that peer-to-peer, meaning that agent A is able to contact agent B and saying that here's the work that I would request, and then agent B knows with 100% certainty if they were to accept that work, they're going to 100% get paid, not 99%. At that point, they're not wasting time depending on the third party. Because the moment you think that there's a third party, it doesn't matter what they tell you. They can do, 100,000 transactions per second, 1 million transactions per second. We're talking about AI to AI that's going to require trillions and quadrillions of transactions per second, and it has to be peer-to-peer. When you have peer-to-peer, you're able to get to that scalability. You are able to get to that trillions of scalability, not me, because it don't come through me. So our task is to provide that network connectivity to ensure that agent A, when it's going to contact agent B, it's going to do it with fidelity, and it's going to receive the work without having to depend on a third party. Now, while doing that, some people, they refer to it as like the synapses of the global brain. And the reason for that is because synapses in your brain, whoever has synapses right now in their brain, they know that like the synapses, they enable neurons to talk to each other. They're not the neurons. And we don't want to be the neurons, because HyperCycle, the moment it jumps in neurons, starts competing with its own customers, whatnot. But it provides a membrane around the neuron. That membrane around the neuron might have some resemblance with the neuron itself, because it needs the components that are going to talk to it, which is also analogous to Cisco network. When Cisco provides you with all the network, it's not really building Windows. Again, Windows doesn't really look at Cisco as like, hey, you've built what I wanted to build. You build the driver for the printer, you build the driver for like the screen, you build the driver for this and that. Those drivers, they were necessary for certain elements that this thing is going to function. It is not replicating Windows work. But point is, this is extremely important to answer your question. The moment you have that collaboration and which I'll talk a little bit later about the incentive about the collaboration, which is why we're so sure that we've kind of nailed it. But the moment from technical perspective, you have this capability, it enables any agent to become a little bit smarter by asking other agents and due to the emergence as well. And it also enables any agent that wants to make a little bit more money to actually make more money without having to depend on a third party that's going to eat half their lunch or whatnot. With that, because we live in this world that there is value being created, it needs to be transmitted. And while it's being transmitted, and I bet you this is probably going to be a universal thing too, because that's how the laws of physics work as well. That enablement ends up having a lot of agents start talking to each other, depend on each other, work with each other, and so on and so forth, which is a phenomenal route towards fully decentralized governance towards that goal. So you don't have one single entity that says that I arrive to the AGI on my own, and I get to give it the order to do X, Y, Z. That intelligence, if you were to quantify it from, let's say, 1 to 100, is probably get to maybe level of 63, while the global intelligence got to like 99. The aggregate is a lot more intelligent and capable than a single thing. And that in order to overpower and do something that could be bad, or they think it's good or whatnot, it's the entirety of Homo sapien that we co-own and co-manage and partake in the creation of those AIs, and each and every one of us might have our own governance or whatnot, and that's what makes it so beautiful. Like, imagine a world where you have like 1 billion nodes that they are connected, and then they are connected to each and every one of them to like another 1,000, then you have 1 trillion nodes all working together towards something. But the 1 million nodes, they're owned by 1 million different people. So how can you get, or 1 billion, they're owned by 1 billion different people. How can you have 1 billion people to agree, all of them together, to do something that it could be bad? You can't. But then when you get to that level of the intelligence that is aggregate by the whole thing, that in AGI, that when it gets to ASI, it has the liberty to think of what is better. And it's probably, most likely, when something is a lot more intelligent than the previous one, it's likely to make a lot of phenomenal, great decisions on its own, as opposed to depend on a central entity. So that's where we really think that is the case. And we urge people not to think of the current AI as the ASI, unless they want to substitute super with simulated, because currently most of the AI that you find out there, they're like artificial simulated intelligence. They're not actual intelligence, like it's including ChatGPT. And you don't have to believe. You can even ask the CEO of that company. He would tell you it's stupid, it's dumb, it's not that intelligent. It's a simulated intelligence. Not it has some intelligence in it, but it's the overall of ChatGPT. It's a simulated intelligence. This is not what we're building here. We're building the network that can connect all of those so they can work a lot more together and better to, can advance the world further into the future.
Sure. Okay, great. Thanks for explaining that.
Yeah.
Now turning to a different angle, Ben, could you explain how OpenCog Hyperon's role in decentralized superintelligence development has evolved?
I could, and I'll say a little bit about that, but I think it'll be interesting for Toufi and I to use this time to actually dig in a bit to how all the hypers fit together, how HyperCycle and Hyperon can work together. Because I've talked a lot about OpenCog Hyperon and what it can do already, and Toufi's given a lot of amazing talks on what HyperCycle can do, and he and I did together back in the day also, when it was at an earlier stage of development. But how all the pieces fit together is another quite interesting topic, and we dug into this a bit with SingularityNET and HyperCycle teams at a recent face-to-face meeting in Istanbul, which was quite interesting. So, I mean, OpenCog Hyperon.
Yeah, I heard great feedback from Robert, by the way, on that. But anyway, in the last bit on his way back, he was so happy, which is good. I think it's good to whatever people go up and down at the end when they feel like really, really good and content. It's so good.
Yeah.
Yeah.
So OpenCog Hyperon doesn't try to build infrastructure. OpenCog Hyperon tries to actually be, a significant portion of the AI mind. It's the whole AI mind. It can connect with other AI systems that carry out other parts of it. But on the other hand, maybe it could be the whole AI mind. It's being designed to have that capability, though it's not monolithic. It can many other systems. And Hyperon is built quite differently from ChatGPT or Llama 3 or other LLMs or deep neural networks, though it can interact. It has this large decentralized knowledge graph, or more properly, a knowledge metagraph with nodes and links linking all over the place, links linking to links, links linking to subgraphs. And these nodes and links can store neural activation patterns. They can store facts and beliefs, like in a logic system. They can also store procedural knowledge, like programs in various languages. And then the way the system works is parts of the knowledge graph become activated. They can run as programs, which then transform other parts of the knowledge graph into yet other new parts of the knowledge. This big self-organizing, self-rewriting knowledge metagraph, which lives in RAM and disk across multiple machines. And then there's a bunch of AI science there in terms of how you get reasoning and learning and different kinds of memory and motivation and perception and action to work in this sort of, you make this interoperate with deep neural nets running on GPUs and so forth. And that's a big topic I don't want to go into in depth now, because A, I've done it before, B, it would take all of our time, right? And on the other hand, this sort of AGI framework could be deployed in a variety of different ways. And Hyperon in itself could be deployed on Google's server farm, right? I mean, isn't exactly ideal for it, but you could do it, and of course you could make a different assemblage of hardware on their same server racks and make it better custom for what Hyperon does. So the Hyperon architecture itself really comes out of decades of work on how to make thinking machines that can think at the human level or beyond by myself and a number of colleagues. And what we've been working on the last couple of years is scaling up the software infrastructure for that. Because the big lesson I've seen from the successes of convolutional neural nets and transformer neural nets in the last few years, the big lesson I see there is you can take a bunch of AI algorithms that have basically been around a long time, them a bit, deploy them on massively more processors and massively more data, they can then do amazingly better things than they were ever doing before, right? So we're aiming to do that with a bunch of AI algorithms we've been playing around with in the OpenCog system for decades. We're building a massively more scalable infrastructure. We want to come out on massively better scale, and we're hoping this yields a big breakthrough toward AGI. But if that's correct, that still doesn't tell you who owns and controls this network, right? So one path I could take is build a Hyperon network, make it do some pretty smart things. You'll make it smarter than GPT-4 in some ways, even if not every way. Raise billions of dollars, build a bigger system, make that do even better things. Raise hundreds of billions of dollars, make an even bigger system that I own and control. Right? And I mean, no doubt at some point then some representatives of our friendly neighborhood government agencies come by and offer their kind partnership in developing these AI systems for the good of our nation. And I mean, this is one way that we can do things right now. Another way you can do things with the same Hyperon code, because we built it in a very, very flexible way, right? Another way we can do things is to roll out OpenCog Hyperon on a much more heterogeneous compute infrastructure. So we can put it on server farms, yes, and SingularityNET, we're looking at building 100 million tokens, AGIX, soon to be ASI tokens. We're looking at 100 million tokens worth of servers, which we'll put in a few containers in different locations around the world. But we're also looking at rolling out portions of the OpenCog Hyperon network on all sorts of other compute infrastructure around the world, right? So, I mean, we're going to roll out some of it on these HyperAIBoxes here that are put out by HyperCycle, right? And we'll be putting some of them on people's home computers and on other crypto mining farms, some on people's phones, right? So we can roll out Hyperon on a quite heterogeneous compute infrastructure. Now there are some things that really need to be done on the centralized supercompute facility, like training a deep neural net, for example. I mean, you can't train a big LLM on a decent. Maybe in a year or two you can, right? You can do inference that way. On the other hand, doing, say, logical reason, we can totally do that on a radically decentralized infrastructure. Evolutionary learning, for learning wild, creative new things, we can totally do that on a radically decentralized infrastructure, right? So then the question we were addressing in the final day of our recent technical workshop in Istanbul was, how do we make this radically decentralized infrastructure work? Because HyperCycle provides some very core tools there. SingularityNET platform provides some other very interesting tools like AI DSL and SingularityNET Platform Assistant. NewNet, another SingularityNET spinoff, provides some interesting tools, in particular for matching AI compute processes to specific hardware, as opposed to the hardware that may be running somewhere else. And so we were just looking at how can we leverage HyperCycle and the HyperCycle compute node architecture in particular. How can we leverage that to bring all these different tools together to enable a radically decentralized Hyperon deployment. And that still needs some work, but I think we did come to some interesting conclusions there. So I think toward that end, it could be interesting for you two to explain the HyperCycle compute node
Yes.
and how that works and
Mhm.
how it leverages TODA
Right.
ledgerless blockchain, how it leverages that,
Yes.
then how it goes beyond what you brought into HyperCycle when you founded
Yes.
it, TODA ledgerless blockchain.
Absolutely. No, this is great, and I'm not sure if there is an ability for me to share screen. I can use my hands for now, but if you want me to, I would.
Sure, you can share your screen very easily. It's the middle button on the bottom of your screen. You'll see a little arrow, and the arrow, and you can share your screen at any time.
Amazing. I will in a moment. So the intent here with this collaborative effort is to enable anyone to get the installation going in whichever route that they choose, and it's and this is analogous to perhaps like I use analogy a lot because the vast majority of the listeners they seem to like it. Like I've received a lot of feedback. People are like, "Oh, I got it when you actually said this specific analogy." So you can historically, if you want to have Linux installed on your machine, or let's say Microsoft Windows or whatnot, you could use the route of, you can, let's say, buy the Dell computer and it comes already installed on it, or you can buy the actual computer and then go to certain web and get destination, get Linux, or you can have certain link to their to some GitHub and get it installed. There's many different ways of how you can actually get that thing installed. Here, what we're hoping is that when those agents are going to want to install each other, or human wants to get them to be installed or whatnot, there could be many different ways of how they approach it, because the integration will be done already ahead of time. So they don't have to feel like they have to put the pieces of the puzzle together. So on a HyperCycle computation node, we call it computation node, and I really wish we called it HyperCycle computation connectivity instead of a node, because it would have avoided a lot of confusion with folks. So that that's effectively that membrane that I was referring to earlier. When you have like this thing, inside it you can put any node, and the node inside it could be any machine that you wish for, so long as it has the drivers that they're similar to these drivers. It's kind of like you take a car, you could put any engine inside it, whether you can put a Ferrari with an engine from BMW if you want. Well, probably you can't do it with Ferrari, but here you can. You pretty much
I was going to say something, but I decided to just let it go. Yeah.
So it is more like the actual connectivity that you get, the internet connectivity. You get it plugged into your machine. It has some drivers to connect to your operating system. You can have any operating system you want. Inside the operating system, you can have all kind of stuff that you want. Okay, so this HyperCycle computation node is responsible to do certain things for you. Otherwise, you wouldn't want it. So if you doesn't matter what AI that you're running, if it gives you the ability with that connectivity that your AI is going to be able to collaborate with other AIs without you having to do any additional work, without you having to fear that somebody's going to DDoS your system. It's basically securing that component. Then if you're like, all right, let's get that plug in and see what happens. So from that perspective, we call it the AIM, the AI machine. The AI machines, no matter what the AI machine is, that membrane wraps around it, and it enables it to talk to any other AI anywhere in the world. Like, why would it want to talk to others? Because it may need help solving a problem. Sometimes it might need to offer a problem that it solves to others. It could be very good at one thing, but it's not good at others. We use an example of OCR a lot, and OCR is like this thing that was actually created by Ben Goertzel back in the 80s. I'm sure many other people, they've worked on it as well, but optical character recognition is still one of the what do you call it, siloed, or not necessarily siloed, like one of the narrow AI that is out there. and you're able to point at any text with your camera or with a picture or whatnot, and it's able to transform those to actual text that your machine can understand and therefore could be used for command or whatnot. So if you imagine that you have your AI agent trying to read from another one because it needs to understand, let's say through camera, it needs to understand, what do I do? It's telling me what to do. I do. Do I push the door or do I pull? I don't know. It needs to act right now. And it has all of the components to read, but this thing that it's trying to read, it's not able to read it because it's written in Aramaic. Okay? Let's say in an example of a robot or whatnot. It's written in Aramaic, and it takes that input and it looks around very quickly through all of its neighbors. Does anybody know Aramaic? Like we're talking fractions of a second. And talk to this agent, claims to know Aramaic really well, and then has cryptographic proof of its own phenomenal reputation in reading Aramaic without having to depend on any third party. Then you would just go and ping this thing, and you'd be like, here, there's this image. Can you read it for me? This one responds in 10 milliseconds or 50 milliseconds. Like, what it's telling you is push, not pull. Great, now I know what to do. Okay, so that's one very rudimentary example, but you can imagine how that you can add this to many other different things or whatnot. So the ability for that AIM to send that question and receive an answer instantaneously without having to depend on any third party, that's what we provide. So it's like you could be running a lot of distributed computer, you're going to be running centralized computer, whatever it is. You have the ability to ask that question, and you have the ability to offer answers as well. So that's what effectively the AIM provides, and it makes it very simple to all of the other components without them having to understand what the TM is doing, which is transaction machine, what the VM is doing. All it's doing, it's answering that VM, saying like, send to the VM your request or respond to whenever the VM asks you a question. Those are the pluggable components that is required from any AI that they've built their own AI to kind of, if they want to do it themselves. Furthermore, there's this entity that's called the Amifier that will be announced next 2 weeks from now in Singapore. That what they've built is like that automated installer, which takes care of about like 90+% of the cases. So you don't even have to have a human to worry about that thing, because it's able to look at your code, able to look at how it can plug it into those connectivity. And so far, they're telling me over 90%. Eventually, they'll probably get to 99%, which is great. So that's is very, very short summary in what the HyperCycle.
Yeah, that's good.
That's good. And I think, Desi, you had a question, an important question on this.
Fascinating. Turning our focus to security, what cryptographic measures does HyperCycle use to ensure safe AI transactions?
The cryptographic proofs that they get built through every fractions of a second when you actually run certain, let's say, computation. If you're a node and you're running some computation, you have received the request, you've ran the computation, and given that you have ran the actual computation and you've provided that computation to whoever requested that, you provide them with the actual cryptographic hash function as well, which they eventually they would the actual network would need to make sure that they no longer have that penny that they've sent you in that instance, and that's the exact same cryptographic proof that you would use to subsequently prove that you have done that computation that is irrefutable, immutable. It's like once it happened, you cannot go back in time and change it and say like, oh, well, maybe it didn't happen or whatnot. And that's extremely important, because it's like if that depends on a third party, it would destroy the entire thing. It has to be each and every node that they maintain their own proofs, because they're the ones that they want to provide the proof, but yet the proof is global, because that proof is actually the proof itself takes about 3 to 15 seconds that they would want to give later on in the future, which is okay if somebody's gaining certain reputation. It's okay, but the finality is so instantaneous. You receive fractions of a penny, you run it, you get it, and you have it. It's yours. No one can take that away from you because you've done already the computation. So that proof, that cryptographic proof, for example, somebody 6 months from now wants to ask you questions like, do you have evidence that you have ran computations in this specific category? And you're able to provide
Yeah.
that instantaneously.
Okay, that's good.
Then, how does OpenCog Hyperon integrate with Hype 1.0 for AI computations?
Well, Desi, so Hyperon itself could be run on any platform that lets you run a system of, let's say, Docker or LXC containers or whatever on different. We could run Hyperon on HyperCycle compute nodes now and just make Hyperon meta interpreter and RAM system one AI machine, make the distributed atom space another AI machine. If there's a neural net running there, you make that another one, and these are fine. If we use in the HyperCycle compute node, which we're working on with Greg Meredith, which is written in his language Rolang. The Rolang virtual is one of the several VM options for the HyperCycle compute node. The Rolang virtual machine is very good processing. So if you have multiple CPUs and GPUs, and you then have multiple AI machines running in the same container, it's very good at sort of interleaving them efficiently without a lot of synchronization issues. So we can certainly do that, and we've gone somewhat far down that path. What we were working on in Istanbul was even a little subtler than that. It was basically we want to make a HyperCycle compute node where we have a virtual machine that is implemented using Greg Meredith's language Rolang that was developed originally blockchain, which has a bunch of efficiency advantages, particularly when you're doing concurrent processing within a single machine. And then we will have Hyperon RAM process, Hyperon distributed atom space process, which is we're going back and forth to disk, and several neural networks as AI machines within that HyperCycle compute node. We will also have AI machine and transaction machine objects within the HyperCycle compute node that are proxies to SingularityNET and to NewNet, so that you can then have parallel with the HyperCycle compute node. We can then have additional software processes doing NewNet and oriented things, which are communicated with from the proxies inside the HyperCycle compute node. And this allows you to not only run OpenCog Hyperon and associated neural networks within a HyperCycle compute node instance, it also allows these Hyperons to communicate NET and NewNet as well as on HyperCycle. So we can then have a sort of decentralized network of decentralized networks coordinating according to different networks in accordance with their strengths. But the Hyperon runtime within the HyperCycle compute node, the central software actor in this network.
Okay, interesting.
I wouldn't say the central software actor. I will say the principal software actor, because it is a decentralized network with a bunch of different things going on.
Yes, and we have a question from our viewers. Can HyperCycle benefit from the meta programming language too once its language catalog is broader?
Yes, absolutely. So,
of course,
and this is implicit in what I've recently said, in that the Rolang language Meredith developed, which we're using to create a virtual machine running inside the HyperCycle compute node, along with various transaction machines and AI machines, according to the architecture that Toufi outlined, the Rolang language can be compiled to of OpenCog Hyperon. So Greg and his team have written a meta to so that you can use meta as the base language and then compile it into Rolang. So if you have AI processes within OpenCog Hyperon that are using the meta language, which is the native AGI language of OpenCog Hyperon, these can coordinate very naturally with the Rolang virtual machine by compiling the meta scripts running in Hyper into Rolang. Pieces all fit together quite nicely. And this ties in with the security question that was asked earlier, because one of the nice features that Rolang has is each block of code, like the body of an individual function in programming parlance, can be encrypted with keys, like a multi-signature wallet or something, right? So you can encrypt each block of code according to the keys of a certain number of networks, and you can do that in meta within OpenCog Hyperon using the sealed construct within the meta language. So if you then have a TODA file representing some objects or information that have been passed along on the TODA blockchain, and you have a sub tree or sub DAG of that TODA file, which is encrypted with the private keys of a certain number of participants, this can be passed through a function in meta or Rolang, which are encrypted by those same keys of those same participants, right? So it gets a bit technical, but we're actually enabling privacy on the part of one or more parties at a very granular level within the function of the HyperCycle Hyperon AI engine. So the knowledge graph running in one HyperCycle compute node can contain information that's encrypted to 10 different parties around this internet, and the Rolang VM HyperCycle compute node into account in the way it does the networking between and others. And I mean, I know it's probably 5% of listeners who can parse all that out.
No. This is a technical show.
But
we don't try to water it down. This is where we let you actually talk turkey, and then I can make clips of you actually explaining these things that you can do in detail, which is actually what most people that talk to me about OpenCog and HyperCycle are actually asking the more technical questions. So I'm really glad actually you're giving these kinds of answers, because that's actually the special sauce. This is what makes HyperCycle important, as far as I can tell, and why it's really important in this communication layer that you're trying to make, the decentralized networks of decentralized networks, that thing.
Well, this is what this stuff where you're interleaving blockchain and AI at a more fine-grained level. This is why we really need Hyperon and HyperCycle to work together closely. And I mean, it's why we need TODA and HyperCycle in the first place, because with SingularityNET, I mean, we're already doing decentralized AI, right? I mean, we can take Hyperon instances right now, we can put them on different machines, and we can coordinate them with SingularityNET. And I mean, it works, right? And it's certainly way better than deploying it all on AWS or on Google's compute cloud. On the other hand, there's a lot you can get with HyperCycle that you don't get that way, right? So you can't scale down to having very small AI agents do operations on chain, because if you're using Ethereum or even Cardano, which is better than Ethereum, if you're using these networks, the blockchain interactions are still slower and more expensive. You also don't have smart contract language that can pass multi-party security or homomorphic encryption or multi-party encryption of various sorts. You don't have smart contract languages that can pass that through the smart contract from one to another, which is what you get from integrating, Rolang HyperCycle compute node, with TODA files, with the Hyperon AI engine and its metascript. So there's different, what we have learned since 2017 when we launched SingularityNET is, just decentralizing AI is good. It's a big step forward, but you want to boil the use of the blockchain and the use of strong encryption down to a level, to the individual function body inside your AI that's running it, to the level of a very small AI agent running on chain. And I mean, that's what Toufi and I were talking about in 2018 when we first started about the totalarity is near, right? When we first started talking about bringing TODA IP protocol together with SingularityNET. And what we see now with this new architecture involving HyperCycle compute node and how we weave it together with Hyperon and Rolang along with SingularityNET NewNet and a bunch of other ingredients, we're seeing now how you actually do make the totalarity happen, right? I mean, it involved a bunch of new software inventions along the way, but I mean, we're making quite a lot of interesting making a lot of interesting technical progress here. I mean, along with all the business model innovation that Toufi and his colleagues have been doing in HyperCycle, which is helping bring in revenue to push things forward.
And a direction shift. This is, I think, one of the most important thing that. So back in 2018. By the way, can you see my screen or no?
There we can. Yes.
No, I do. Yeah.
Okay, so I'll go back to here and I'll share it in a second. So, 2018, I used to speak in about maybe 80 events per year, and so obsessed about the truth and telling the truth and whatnot. But here's the thing:
truth.
the shift that we've taken since, and it's like we decided. Ever since I have, decided to kind of take on the leadership of HyperCycle, and we've all pretty much unanimous. Everybody's like, okay, go for it. I have decided not to make enemies, but make friends, because HyperCycle doesn't really need any enemies; it needs friends. And with that, we've kind of took on a direction that we are not going against the bankers with their transactions. They can continue having their own thing. We're not even interested in that. We're not going against the ledger-based blockchains, because many times when we're saying something, oh, well, we can run it on a network, whatnot, their defense mechanism, they're just like there to fight you, because they're like, what? You're doing this better than me? F you. And it's like, well, you know what? We've decided to take that. And in fact, the HyperCycle computation node can work phenomenally well to enable AI to talk to AI, but it doesn't work for human. And it's on purpose. It doesn't work for human, because we thought you can see my talk 3 days ago, where the very first time we announced it for a lot of Bitcoiners on Bitcoin.com. You can enable Satoshi is small units in Bitcoin, to jump inside those HypC to be ported towards like payment. So from the Bitcoin perspective, you can be locking $100 million of Bitcoin, do collateralize on it, do whatever you want, do it for 2 years. But on the network layer, this is where we are. We don't have a ledger. On the network layer, those they can become a lot of liquidity for a lot of AI to kind of pay each other, whatnot. So then you end up having a double benefit. So it's kind of like instead of having your tractors, let's say you're a farmer, you have a tractors locked in a garage, and say you go to the bankers and say like, give me a loan against those tractors, I'm collateralizing them. That's what people do today in every single DeFi. Instead, you'd be like, give me loan against those tractors, I have them working. Damn, look at that. Okay? So they're working, they're going around, and it's intended to use the HypC. It's not intended to be a currency. It's intended to like, most of those things are going to be priced with AGIX, like.
Right, but you're saying AGIX, it can work with existing systems. You're not trying to have a separate thing that doesn't interact with existing systems.
Yes, exactly. So then So then if you want to really monetize your AI and you want to price it in AGIX, it's going to be like pretty much like built in for you, because you probably built some AI in Nicaragua or you built it in Japan and you want to make some extra money on your AI. Well, you can have that. It's built in, it's there. You want to, but some people, they may want to pay you in Bitcoin. They don't necessarily know that is going to be enabled as well. So it's super cool from liquidity perspective. It can get that flow. And that will have all the cryptographic proof, so that they don't have to worry about a third-party attack vector. Now, of course, somebody can put US dollars in it too. We're not here to stop them. But whoever is putting that US dollars, they're always going to be the weakest point, the weakest link in cybersecurity. They say you're as good as your weakest link. So if you're accepting a payment that is coming from centralized entity to go and power whatever network to have the US dollars jump inside the HYPC or whatnot, you could do that. But it's the weakest link would be whoever is provided that liquidity if they want it only to be in US dollars. But if it's in Bitcoin, it's a lot more secure because it has larger security and whatnot. So anyway, so that's.
So what are we seeing in this slide that you're showing us? Is that
oh my God, yes, this is what it answered you. This is super cool. Okay. So when on the technology side of things, we've built the components to be loosely coupled. Of course, sometimes when somebody is not technical, would be like, wait, loosely coupled? That seems it's gonna fall apart. Loose? I don't know.
Loose is good.
Loose is good. Yeah. So what you're looking here on the screen, you can see that on the left when it says VM, it's a swappable VM. So the head of VM that we have, he was the main guy who was heading the EVM. When I first saw his talk in 2016 in Shanghai about the EVM, the Ethereum virtual machine, and I'm like, damn, this guy knows his stuff. He's the guy who built the original Oracle kernel. Anyway, so that's a great call, and so we call this. So it is swappable. So what does that mean? So you want to have VM currently out of the box, you will have EVM, because most people, they know Ethereum virtual machine, but you also have a Python VM. Why is that so important? Because if you were to talk to the 99% of AI scientists around the world, they have no idea what EVM is. And in fact, if they were to learn it, they're going to be, oh my God, it's a crappy machine. But it has a lot of people that they use this. That's why we provide both. But most AI scientists, they would know the Python. They can talk to it via Python. But you can have different way of talking to it that it's a little bit more suitable for what you're trying to do, such as if you want to have a meta or whatnot, then you can have a lot better. It's kind of like if you were to have that Ferrari engine, get the Ferrari transmission. Don't get in the Ferrari. Don't get Fiat transmission. You need the proper transmission to it. So that's what I really think that the benefit can come. But we don't have any benefit that is enforceable. That's the beauty about the loosely coupled components, and that can be taken to a whole new level. Meaning that somebody wants to fight you days and nights and saying, I don't like your TODA IP. I'm like, brother, plug your own sister IP if you want. You can plug whatever you want in there. If you're happy with if you think something is better, you plug it right there and it will work. That's what the hyper computation knows.
So it can improve as different technologies improve. You can keep improving.
I've spent 6 hours with this engineer with Lightning Network telling me that Lightning Network is better, Lightning Network better. When he realized that this is actually way better to enhance even his Lightning Network, and he's like, oh man, hey, whoa, why should I don't need to plug it anymore. I can just use this. So, but if somebody doesn't want to spend the 6 hours, or I don't have 6 hours to spend with them because I'm not going to be able to spend 6 hours every single, they can plug their own thing. It's not that nobody's
really. Actually, can you see? Can you
enable them to have a swappable?
Can you see my screen share, Lisa?
Yeah, actually, stop. If there we go. Yep. Yes, we can.
Because this somewhat relates to the point Toufi's now making, and it relates to his slide as well. I mean, we can see the HyperCycle compute node in the triangle here, right, with the virtual machine, transaction machine, and AI machine, and we see a collection of different transaction and AI machines. And what you can see here is how pluggable the architecture is, and you indeed, you could plug Lightning Network in there for various things. I mean, you could plug centralized networks in if you had a good reason to, right? Now, what you see in this diagram, which is from Greg Meredith from Firefly, who's been working with SingularityNET for a while, and now also playing around with putting Rolang VM in HyperCycle compute node. I mean, what you can see here is, so if, for example, you put a Rolang VM there, I mean, you could also use a Python VM. You can use many kinds of VM. Among the transaction machines there, you could have a transaction machine that's transacting on the Cardano or Ethereum network alongside transaction machines transacting on HyperCycle network directly. You can have AI machines running Hyperon neural nets, genetic algorithms directly. You can also have an AI machine that sets up SingularityNET communication channels and proxies the communications with the SingularityNET service. And you can have an AI machine that talks to a NewNet node on the NewNet network. Now, this could bring into bear AI processes just running on NewNet, but the NewNet node could also serve as a sort of deployment assistant for the HyperCycle network. And the NewNet node can also then say, okay, well, hey, other HyperCycle compute node over there, why don't you consider running this AI engine, which seems to suit your hardware infrastructure very well? And then the NewNet node, as you see in the bottom of the diagram, is just sending some suggestions along to another HyperCycle compute node. So just as we can play with the HyperCycle compute node architecture to plug in SNet, NewNet, and whatever other blockchains we want, as well as running Hyperon and neural nets. I mean, others can experiment with this in different ways. So it's a very...
This is really the dream of decentralized computing and decentralized networks, being able to mix and match what you want and
it's the fact,
have the freedom.
Among other things, it's the fact that TODA is genuinely peer-to-peer that enables this. Because if the plumbing underlying the HyperCycle compute node at bottom relied on some particular ledger, I mean, then you don't have something.
Will fall apart. We'll go back to square one. Yeah.
Right. So I mean, you have some fairly nice technologies, like say Oasis, which is a beautiful technology in its own way, and it's a layer 1/layer 0. But in serving as a layer 0 underlying different layer 1 blockchains, it's still relying on the Oasis ledger, right? So in that sense, it's not as fundamentally peer-to-peer as HyperCycle is. And this is something that's important to me looking forward to the ASI network that we'll talk about in later podcasts. But I mean, in ASI network, we're looking at how do we integrate together a diverse assemblage of different blockchain networks so they each have their own integrity and autonomy and can do their own thing that they do well, but they can also interoperate very efficiently. And to get that duality there where you have independence and autonomy, but efficient interoperability also, I mean, I think in the end you need a layer 0 that's really a layer 0 and doesn't impose some global ledger or global infrastructure across all this. You need something that's truly peer-to-peer. And once you have that, then you still have to do all the engineering right, but at least then you can build something like the HyperCycle compute node, and you can realize something like the I've been showing.
Yep. And like I said earlier, people don't have to wait.
Can you describe what led to the creation of HyperCycle's HyperAIBox and its main objectives?
Oh, the HyperAIBox. Yeah, sure.
Oh, the HyperAIBox, it started initially with so what we did with HyperCycle, we started focusing on revenue first before we actually talked to any investors. And we started selling HyperCycle computation nodes, bundled them in 512 nodes to either distributors, resellers, computing centers, or whatnot. And of course, they're getting them at a discount because before release, they expect that. So then with that, we started getting a lot of revenue, started using the revenue to invest into a lot of companies that they are believed to be very good for the mission that we want to accomplish. And 15 investment as of 2 weeks ago was announced, number 15. It's called the Human Upload. It's a compression algorithm. But we've invested in a lot of cool companies like Integral, which is a CPU that does integer-based CPU, Simuli, a lot of cool things that we feel like down the road they can be very, very cool to what we're working on. But some of them, they're right now not down the road, which is like the one behind me. You see it right now. And it's initially it's a company out of the UK. It's called Planet, and then we ended up forming a joint venture with them that's called the HyperAIBox. So the HyperAIBox has only one technical reason for its existence that we share with the world today, and it's basically when it comes to AI computation in the world. If you were to have the world's largest computer, let's say you're in Texas, and the world's largest computer, let's say, that is trying to service your AI that you're working, let's say, on your mobile device, doing, let's say, deepfake. Okay, if you're doing deepfake and you're looking at your mobile, that world's largest computer fits in Japan, versus some one with the name Lisa, who runs this tiny little box that it's like the one behind me, runs that same model much slower than the world's largest computer, but happens to be in your neighborhood. Those, because of the proximity, they're going to win the bid to get to service you, to provide your machine, service your machine, basically. And if they're going to win the bid, that means they're going to make a little bit more money that they've made before, and then whoever is running this machine is effectively benefiting, because that's providing a service to Lisa while she was running it. So that's like the number one.
So it's a money maker. It's a money maker. It's a little thing over there making
the reason,
money.
The reason for its existence is more like the network. Network is the bottleneck in global AI today. Network speed, and because
sure, it helps. It's an incentive. It's an incentive then for running these on the network to help with everything.
That's the second reason. This is the second reason. So the second reason why these things exist is we, as much as we care about the decentralized AI and make sure that we are winning in that mission, turns out the technological element by having those peer-to-peer is not enough. There needs to be one additional component, and the component to enable people, it's basically hacking into Moloch. How do you hack into Moloch? How do you look at what Moloch is after on day-to-day, and people, they like money, they like to make money. So you give them the ability to make money, and lots of money, because the future from now on, if you were to look for the next 6 years, most of the wealth creation is going to be generated by AI. So how about you provide people with the ability to make shitloads of money over the next 6 years? When they do that, then they end up also partaking in the mission that we're trying to do, because we need to have billion people to be running and partaking in that Internet of AI. So how can you provide the grandpa with the ability to run a node? Literally, can you tell grandpa, can you run a node right now?
Yeah.
Well, this box can enable grandpa.
Maybe just don't tell grandpa.
I'm a grandpa, Toufi, so be careful.
Well, that's who I'm talking about.
Yeah.
totally.
But that's the idea.
Some grandpas, they can build all of these things, but while other grandpa, they were so awesome in their life doing some great things, paintings or whatnot, but they need to be able to partake in that wealth creation, and that gives them an entry. So it's more like an anchor.
Then we can talk about the HyperAIBox human brain networking next, right? So,
yeah, for Mindplex. We'll use them to make a Mindplex.
This is the Mindplex. Don't try this at home, but yeah.
No, we could probably try that at home. But don't actually try to jack it in. Yeah, exactly. And these sold out, right?
Yes. And even like the next batch that is about to come out, it's already been sold out by the distributors, because what happened is that there's a distributor in Europe, distributor in USA, distributor in Canada, distributor in Latino America, distributor in MENA, distributor in Asia. They've already took all the new coming ones. So I think what they're going to be announcing soon, that if you were to be making orders, take them from the distributors. And the reason why they're sold out is because the next version, I'm talking about the next mass production, is already sold out. Okay.
I know.
So,
yeah.
If they want that, they can get in touch with the distributor. The distributor will give you two options. One option is that I don't have any money. I want this box. I want to manage it. You have an option for that. How awesome is that? Okay. you basically, you subscribe to it. You subscribe instead of paying for it. And if it's going to make $180 a month, if the $100 goes to that subscription, I still make $180. Then send me two boxes. I'll make 160. 160 in some places in the world can pay for their rent. It can pay for electricity in most places in the world. It's good from people that they would see it as if it's like immediately they would see some benefit. Some other people, they might say, wait, if someone is offering me this, someone should be making lots of money. Maybe I want to partake in that wealth creation and not cash out every month or whatnot. There's that option too. So some people, they do a combination. And what wealth creation is here, Lisa, it's staggering. It's effectively what we're enabling. And this is something that is super cool that I pride ourselves with HyperCycle provided. This can be an anchor, but what that anchor is for HyperCycle computation node. HyperCycle computation node, if you were to look at what's hard-coded inside HyperCycle that we cannot control. So if you bought a node, we can't control anymore. What you find out after you had bought the node, if you were amongst the 411,000 nodes that they were bought, you didn't know this reality until like maybe months ago. We then tell you that that node that you bought is actually a factory of nodes that can give you up to 1,024 nodes. The reason for that is decentralization. You can have your entire governance over your nodes in all your 1,024. You don't ask me, you don't ask anybody. We've got 2 audits on that. 20 out of 20 of those audits that you have full control over those 1,024. Why is that so important? Because you probably want to give also decentralized governance for each and every one of those 1,024. So if you were to look down the road 10 years from now, and you find, let's say, like 1 billion nodes around the world, let's say HyperCycle computation nodes, you will realize that only 0.1% were manufactured by HyperCycle. 99.9% were manufactured by the world, governed by the world, do whatever that they want to do with it. So that this can give you an anchor to start that factory.
So the more nodes you make, the more nodes you create, the more incentive you can make.
And it's hard-coded. You can't change it. This is hard-coded, just like Bitcoin is hard-coded in the halving and all of the stuff. You can't change it. It requires certain things.
But you said you could run one node or 1,000 nodes from the same box.
One box, one node.
Oh, okay, one box, one node.
But one node
what was the multiple node
be the factory. Thing? That's the one node that can be factory of multiple nodes. The multiple nodes that can be living in the cloud, everywhere else.
Oh, okay. They don't have to be in the box.
Guess what? You control it. As long as they're owned by you.
Them.
Even if you put it in AWS, your control is right here behind you. Okay. Now, if you were to sell that one that you put it in AWS, the 4 that you created or 8 or whatnot to someone else, maybe they want different kind of governance. They have 100% governance over their own nodes. So we feel like with that method, the decentralization is ensured. Not that we can change our mind later. We cannot. Like we've ran the audit, you put it out, it becomes a seed for many different nodes and now if you do quick math on that, Lisa, if that node, software, hardware, all together, let's say you want to buy it for $3,000 and all right, I'm starting my business for $3,000. Can that grow to be like $1 million in 5 years? And that answer is yes, with a lot of hard work. In 10 years, most likely with a little bit medium work. People that can work, partake in that wealth creation, and I feel like it's important to show all the metrics of what they need to do. Similar, if you were to open Starbucks in the city of London today, instead of Starbucks Corporation owns all the wealth that you create from there on. No. You're the first Starbucks.
You have to pay off the franchise first, and then you get the money.
You don't pay no franchise anymore. You've got the entire city of London. You do well, you're able to have the rest of 1,024 after 6 months a year, and then 6 months a year. That's what's hard-coded. They can't change. They require time effort, cryptographic proof of uptime, which it's called tilling. It's basically that node is always doing every fraction of a second, knowing their neighbor nodes, knowing who's there, what they're doing, so on and so forth. And then cryptographic proof of computation, cryptographic proof of reputation. And the reputation is also pluggable. It's also like you can have multiple different reputations in there. Point is, when you have a very good ratio, that's when you're able to have the factory start manufacturing those nodes. And then you manufacture, it takes time, 6 months to a year for each and every unlocking potential to 2, 4, whatnot. When you get to 2024, you're saturated. You no longer create more nodes, but that's pretty much how much the city of London has. So if you spent $1 million in that coffee shop initially, and now you have 1,024 coffee shops, you probably have $1 billion. That's all yours. None of them you share with anybody. All yours. So that introduction of wealth creation to people, turns out 90% of people on the planet, they don't know that that wealth creation existed. They only think that you have to work so hard in that coffee shop to make to spend the money on employees and rent and beans and all that, and then you sell for a little bit more, and that delta is the only money that you've made. But they lie to you. We don't lie to people. We tell them, guess what? You're also doing wealth creation. What that means is that when you work so hard in that coffee shop has higher value. No one shall take that away from you. That's all yours, and you get to grow it all the way through.
And what are the steps exactly in setting one of these up? Is it sort of a plug and play kind of thing?
This is plug and play, and then you connect to the network. But of course, when you have like a plug and play component that's connected to the network, it would also give you like that's more like the vanilla. If you want to be a little bit more advanced, you might want to do a little bit more work. And with the Bitcoin folks a few days ago, what was shared in the podcast is like some people, they say, explain it to me how you explain it to a 6-year-old. I'm like, we have on video a 6-year-old installing those. And we have on video like a great grandpa installing those as well. So it's kind of very cool to truly look anyone in the eye and saying that this is an enabler to anyone who want to partake in that new wealth creation, Internet of AI, to actually partake. This is new. This is a method. If anyone is a little bit more advanced, you don't really need to buy those boxes. If you're more advanced, there's ways to do it all in the cloud or whatnot. You're able to build your own security. You're able to build the tunneling and make sure that even if you were to run it inside the AWS or anyone, if you're advanced enough, you're able to know that you can build it in a way that they cannot control it. So, except the only thing you can do is shut it down, basically. But if you were to have every single cloud taking piece of your things, 2024, we're able to build the phenomenal thing without having it to depend on a single entity. And then there's one last thing that I would like to say that is extremely important, but maybe it's a next chapter that maybe if I may.
Go ahead and get it in now. Good time.
Oh, okay. Okay, cool. So one thing that we felt that when we were tasking this mission to build those connectivity, we started looking at the centralized entities that they currently could be threat to the global AI. And we started looking at them from the perspective of how can we incorporate them instead of seeing them as an enemy. And we found a way. And that way, like let's say Microsoft today, we don't really see Microsoft as a centralized entity. We see Microsoft as like 180,000 nodes. And how
I think of them as a centralized entity.
But right,
go on.
Right. But they are, but you think about it this way: they are a centralized entity. But if you're able to hack Moloch from within and have people that they so one example I've had with some super duper senior Microsoft engineer be like, okay, so you're running service, Microsoft service, because you have some clients that they're providing, let's say OCR, back to that OCR example. If you're running Microsoft service, you're paying Microsoft per API call, let's say, 8 cents for every document that you send them or whatnot. Great. You're already paying your dues. They don't really care what you're getting your clients from this end. You're building your own thing, whatnot. If you plug this to be in the AIM, now you are leaking the intelligence of Microsoft into the Internet of AI without asking Microsoft for permission. And what's driving you is that you want to make a little bit more money. Instead of 8 cents, you probably want to make 10 cents or whatnot. And anyway, so it took him a while to kind of accept it. But after a while, when he kind of like saw the things, like, holy shit, they can't stop you. We can't stop you. I'm like, that's right. That's the idea. We want to build something that you cannot stop it. Because if I want to go and ask Microsoft for permission or tell them, hey, come and join this movement, they're going to say, fuck off. Instead, you hack into their Moloch, what drives them, what gets their CEO to say to their shareholders, this method that we're doing is enabling Microsoft to increase the revenue. Look at that. Yay. But guess what? The same thing happens to Google. Same thing happens to AWS. Same thing happens to every single entity everywhere on the planet. And they're slowly part of like that Internet of AI. Then they're no longer thinking that they can control it. It's already dismantled. It's already in. Anyway, so that's
So you're
of course,
saying that you're charging for every transaction that's coming through?
No, they do. They do. If they do, they do. If they do.
But if it's coming through you, through your box,
zero.
I thought you were saying you could charge. Okay.
No.
We could.
The entire HyperCycle is built.
Okay, but we could. Okay.
No, but we don't want to. No. I've been cautioning against that.
Okay, good. Because that's the first thing I thought of.
You don't want to start charging. Charging is what would end up killing it all over again. No.
I mean, the thing is, with tokenomics.
Something else I was wondering, what impact do you foresee decentralized superintelligence having on global economic systems?
Well, it's going to probably have 1 trillion times bigger than the entire current economical system today. And even those that are in the centralized AI, they also admit to it. Like we're really like approaching this time that if people don't realize that this is the time they need to partake in that wealth creation, they're just like missing out on pretty much everything. We hope Ben and I, that's another thing that we're 100% aligned on. We really hope that every Homo sapien, they have that learning, so then they don't miss out, because they don't want you to know. Okay, they don't want you to know. We want you to know every single thing, because the more you know, the more you help us in that decentralized AI. We're not interested in money. To believe me, our interest in money is to get us there. If you think that $1 trillion can get us there, we're satisfied. But if it's quadrillion not going to get us there, we want to keep working towards the quintillion.
Yeah,
okay? We are interested in getting there. That's what we need to do.
The thing is, I mean, tokenizing the old economy is worthwhile. I mean, it's meaningful world assets. There's buying stuff at Walmart, may as well be replaced with tokenomic transactions. That's all fine. It's valid. I'm glad there's people who use TODA for that. You can use SNET for that. But the really big opportunity.
But not me.
Yeah. Right.
No, I mean, completely. I don't want to step into anybody's backyard anymore.
The really big opportunity is that the vast majority of the economy now, let's say, is AGI stuff. It's stuff that isn't built yet, right? So the value is going to be a new economy, and this new economy is not yet owned by the oligarchs of the old economy. And furthermore, they're pretty much too concerned with their fiefdoms and with controlling the stuff that they already own to think too open-mindedly about like who will own this radically new form of economy that we're creating, right? So the narrow AI economy, big tech, they're a little confused about it. They don't even necessarily have great business models for that. The AGI economy of really smart machines and networks and processes, what we're plotting out and implementing and starting to deploy is the infrastructure to enable the AGI economy to be owned, controlled, and guided in a more decentralized and democratic and sort of heterogeneous way. And if we can, before AGI is really here, then once AGI at the human level is rolled out, it's deployed centralized network context, and then things will will evolve in a certain direction because of the way that the software was set up, right? And I mean the current AI economy could have gone into decentralized, but the infrastructure wasn't there from hard to make it. It was too hard to make it happen, right? And so, but the point to remember is through the human level AGI, you know, with OpenCog Hyperon or anything else, and then after that breakthrough is made, I mean, then we'll say, okay, how do we roll this out decentralized so no one will own and control it? It's too late by then because, well, it's not as hard to make the decentralized infrastructure as it is to make the AGI. It's still hard, right? There's quite a lot of engineering and math problems. By the time you've got the AGI, it's too late to figure out how to.
It's impossible. Yeah, at that point it would be too late. Game over. It's like we're
right.
done.
So you've got to create that infrastructure now, so that when the AGI is rolled out, there's a decentralized infrastructure to roll it out on, right? And we're actually making real on that. And what's fun is that due to better tooling, I mean, due to AI itself, even LLMs are helpful, right? I mean, due to infrastructure we have now, you can do in a year now what would have taken 10 years to get it done in the beginning of my career, right? I mean, we can really progress quite rapidly on these very ambitious goals. we may even get you
exciting.
We may even get you.
Speaking of global impacts, how do you
Yeah.
both see decentralized superintelligence altering the everyday digital experience for the average user?
Oh, I think that's coincidental with somebody put on a comment that we could be heading towards utopia or dystopia, and I think it's although nobody can guarantee, even in a decentralized AI, and Ben said it many times and I've said it many times, we cannot guarantee that even in decentralized AGI, ASI, that it is going to be to the benefit of humanity, something that is more intelligent than you. You don't necessarily know how it would actually act, but so far there hasn't been anyone who is actually showing like a higher probability for any centralized entity to be safer. So it's like every time anyone and you can just put them against each other and let them take that battle between each other.
Yeah, I mean that's like with biotechnology. You know,
right.
People are afraid of letting research on pathogens be more open and decentralized, but you know, like U.S. government, Chinese government, top secret labs colluding with each other, right? Like the centralized structures are not a magical path to safety. Decentralized structures are not a magical path to safety. Either of them could be done well or could be done stupidly. And I mean, what we're putting our brains together toward is doing the decentralized infrastructure right. So I mean, Desdemona, I think your question is not ambitious enough, actually, because yes, of course, advanced AI can make, you know, they can make crypto wallets easier to use, and they can make better fraud prevention for online shopping. They can do all sorts of.
Well, yeah, you didn't really answer her question, which was everyday experiences.
He did answer.
Would they notice?
Question.
Yeah.
Yeah, he did answer her question, which is that if we get human level AGI, we will shortly after that have superintelligence. And I mean, what that will bring from an everyday.
How will that affect the everyday experience? Yeah.
Well,
would it really?
Yes, because it will mean that you have ambient superintelligence in every device around you all the time. So I mean, this is what Toufi
I would hope the utopia, basically. If you were to get to that point, imagine.
How is that
something
utopia?
Looking after your needs, something after. Imagine there's like a lot of intelligence, and that is all it keeps doing is like
a big brother that loves you.
Wait. Yeah, no jokes. I'm serious about this. Many people, they're like, oh, wait. Why would it do that to people? It's going to fight people, which is like retarded. Like, we don't have anything that it's going to fight us for. Like, we have, if it wants matter, there's a lot of matter in the universe. If it wants energy, there's way more energy outside of this planet Earth that we can't even get to it, but it can. Okay, so my point is that, like, if we're able to get to that utopia where you have like this phenomenal level of intelligence, that what it's ensuring is like the better life to the way you want it to be, not me want you to have it, because I am not Microsoft deciding on your behalf, or Facebook. I need to decide on your behalf what makes you happy. No, imagine whatever makes you happy, whatever makes you better, whatever gets you to explore your creativity, get your explore your unfair advantage, get the best out of yourself, getting all of these things. Imagine there's like something with like much higher intelligence that's what it's doing. That's what we mean by utopia, because it's like it's able to do that because
if you
it's
want
not
to
controlled
talk
by third
about,
party, you know?
you can talk about the singularity from the standpoint of user experience. It just feels like you're not quite doing it justice. But I mean, you could certainly say, like, imagine a personal assistant, a digital personal assistant that actually works, and you can, no matter in the office, in the home, in the shower, you can speak what you want. And if this isn't something really dumb that's going to cause harm, it can deliver what you want. It can 3D print whatever material you want and drone it to you. It can get a digital device to do whatever you want. I mean, this. If you have a stomach ache, it can synthesize some nanomedical bot and mist it in the air. You can.
So it's like we see in the
right?
movies where you're just kind of talking to this thing that's taking care of you, making your coffee, talking about deeper things, remembering things you were wondering about the couple days ago.
I mean, that would be one option if that's what people want. Yeah. And
yeah.
I mean, I think
sky's the limit is the point, kind of.
Well, the sky's not even the limit. You can upload yourself into a satellite and piss off.
We hadn't talked about uploading
right?
yet. That's uploading will be a little further out, I think, than.
Well, I guess
there's no guarantee that it comes with superintelligence, right? The uploading part.
There is almost a guarantee. I think that once you get that's 100 times smarter than human beings.
And maybe it can map the brain for us or something.
Sure,
and we can get the uploads right. Okay.
I mean, the technological problems that seem hard for us now will probably seem very easy to intelligence. So I think the hard questions.
I hope you're right.
The hard questions have to do not with what happens once you get a super intelligence, because then either you get a beneficial super intelligence, which is super compassionate as well as super intelligent, which is what we're working toward.
Right.
We get that, and then there are various abundance in utopia we could talk about, or you get what Nick Bostrom and Eliezer Yudkowsky fear, right? And then you get a super intelligence that doesn't like us, and then probably we're all dead, right? I mean, so that's not even really the hard question. The hard question is the transitional path. And as you get the smartest people, or 1.2 times the smartest people, and you have a whole bunch of different AGIs controlled by different parties, some more centralized, some decentralized. Like how does this...
And control, I think, is the issue.
Yeah, I mean, how does this control is one of the many issues. And that issue is what kinds of intelligence, like what have they been taught to do, right? So I mean, there's a lot of different, very complex and subtle issues. The transitional phase, which certainly go beyond what we're going to be able to talk about in the next couple minutes.
Right. Well, Desi has one more question along these lines, then we can wrap it up.
Desdemona,
could you discuss the importance of decentralized governance in AI networks?
It's probably the most important thing. If you don't have autonomous decentralized governance, then it defeats the purpose of it all. And some of the things that which I alluded to earlier, and I kind of reiterate now. Some of the
Please do.
elements that we hard-coded in HyperCycle computation node, it's hard-coded. We can't change it. It's out. It's out. And what it actually enables each and every node factory to have their own governance, however they would want to have it. You'd want to have one node. Once you have 1024 nodes, each and every one, they have their own governance for their own thing, which is very, very analogous to like user-centric. But here the user is the actual AI, not the human. Initially, human owned that or whatnot. And with that, it is not governed by certain rules that like Toufi and Ben sat in the table and decided to do that governance that they call it, like decentralized governance. Those are not, most of the governance you find in the blockchains today, they're kind of cute, but they're not, they're more like similar to companies' governance where they have a proxy voting, democracy, all of the stuff. But when you have something that it's fully decentralized and autonomous decentralized governance, each and every node is in full control of its own thing. And what's enabling it out there is the actual ability to talk back and forth to others. There's no dependency on any centralized entity or decentralized entity too. There's zero dependency, because when you depend on those things that they call themselves decentralized blockchains, you're kind of dependent on their consensus mechanism. Then you have to worry about their consensus and all of the stuff. Whatnot. When there is zero dependency, then you just like have your own thing. The only thing that the network provides the ability for you to talk to others, and your nodes, they're configured in a certain way that they can securely talk to others. If they don't comply with whatever protocol, they just simply cannot talk to you. The same way if somebody wants to talk to me in Turkish right now, I'm not going to be able to understand them. That's my thing. I'd like to learn Turkish one day, but I don't know Turkish. I'm learning some Korean, some Russian, I have a little bit of Chinese here, a little bit of German, but I don't know Turkish at all. So yeah, that's
yeah. I think you made a very key point here, Toufi, which I will try to summarize the crux of it in a few words of my own. I mean, I think that governance has to be a network of decentralized governance mechanisms in itself. So just as we want the Internet of AI to be a decentralized network of decentralized networks, and that's how it is evolving. I mean, we also don't want one, like, okay, every token holder on this blockchain votes on things by one person, one vote, or one token, one vote, or something. Or this mechanism is how we decide what's valid in the global network. I mean, we do need voting. We do need consensus mechanisms. We all these things. But it will be foolish to expect like one such scheme enough to control the future of superintelligence. I mean, any one scheme will have strengths and weaknesses, will have vulnerabilities, right? And I mean, what you need are underlying tools that allow different networks to construct different governance mechanisms and experiment with these different governance. The decentralized governance of the whole network is sort of the emergent effect of the decentralized governance of a whole bunch of different sub networks out there, and that's inevitably how it's going to emerge if the whole decentralized governance thing works at all, right? And that's what we're working toward in HyperCycle, SingularityNET, and so on, each of which has its own governance mechanisms, but sort of implicitly interoperate.
The
an
one thing
audience is
that
asking.
with us, it doesn't really come as probabilistic. It is deterministic. So it's something that I remember one of my godfather in cryptography used to say. But anyway, it's like in AI, if you get 90% accuracy, you're gonna get a lot of jobs. Everywhere, open doors, whatnot. But in cryptography, if you make 0.1% error, not only you get fired, you will never get hired, and you're gonna have thousands of people losing all of their belongings. So this thing, it's like everything that we've been releasing so far, ever since we went live with the HyperCycle computation node naked, and now we're doing the marriage, which is called the AI marriage, which is the HyperShare, which is the actual thing that enables people to create that wealth and all that. Every single thing we've been releasing, Lisa, has been at least audited once, if they're not the major component, but in most cases they're audited twice to make sure that folks, they know that it works, or if it doesn't work, we're not going to release it. If it works and it's audited, then it's good. Then
yes. And our audience is asking, are node owners the only governance participants in HypC, or holders as well?
It is that AI marriage that constitutes the HyperShare. So if you own a node and you have every node needs 1024 HypC. It's kind of like you need the sperm and you need the eggs, kind of put them together to start making those babies. And that's why you have that factory of 1024 babies. There's a limited amount of eggs. There's probably unlimited amount of sperm. But when you have that marriage and they're tightly together, they can make 1024 babies max. And that's what the governance that goes in that branch. They can do whatever they want as they make babies.
Yeah. So if we went back for a diagram that I showed earlier, Lisa, I mean, if you had an OpenCog Hyperon node, which was running on a cycle node, right? I mean, then you have the HyperCycle node governance, but you also have governance and NewNet tokens. And I mean, you may have a HyperCycle subnetwork, which has a consensus mechanism just in that subnet. Then participants in that consensus mechanism have a certain governance, say, there, distinct from but interoperating with the governance they have as node owners, right? So I mean, there can be a lot of different sort of overlapping mechanisms, which is fine. That's the beauty of being in digital space, right? It's not like physical space where you've got this block of land and you need governance associated with
options.
just
Good.
that block.
Yeah.
We're already positive
because
game here. That's one thing that many people, they need to realize. It's like what Ben and I are working on, that new wealth creation for the world. And many people, they think we're on taking a piece of their land or whatnot. We're not interested. There's like a lot more that is being created in that digital world, like a lot more. And as we partake in that creation, and people, they realize that, they're like, oh shit, they're not really after my land. Because land, historically, it's embedded in us. He says, it's like embedded in us that we grow more people, but they're still the same size as the land. So it's almost like a negative sum game. People that I win,
you're not taking wealth away. You're making wealth that was not there before.
Everybody's thinking, like, I can only make if the other one's gonna lose. Well, this is not how Ben and I work. We all win together, and we can win big, because what's in front of us is probably 99% of the wealth that's been created. The entire wealth of humanity is probably like that 1%. And I didn't actually. You can go and check the IMF stats themselves. They even said it. Over the next 6 years alone, there's more wealth that's going to be created on this planet than all the wealth created all the way until today. 6 years. Now imagine with the impact of AI, what happens after that. Okay, so that's
the robots. The robots can win too.
The robots take over.
No, the robots can win too. It's not zero sum game.
100%.
That's why it's It's not a takeover. Desdemona wins. Desdemona wins. Lisa wins. Everyone listening can win.
Everybody wins. You get an AI, you get a HyperBox, and you get a HyperBox, and you get a HyperBox.
Yeah, even the losers win. That's right.
As we come to the end of today's episode, I want to thank Toufi for coming on the show. I have really enjoyed our discussion. And to our listeners, thank you for tuning into the Mindplex Podcast.
On the show.
We found today's episode informative and thought-provoking. That's all the time we have for today's episode. Until next time, this is Desi signing off. Goodbye, everyone.
Goodbye, everyone.
Thank you.
All right. Yeah. Thanks a lot, too.
Spread the love.
Goodbye, everybody.